How's it going, everybody? And in today's episode, we have a really good chat with a proper industry expert. Now, he doesn't call himself an expert, but he is an aerospace engineer and he does make bottom brackets for bikes. So, in my opinion, he certainly is an expert. And I think, in no doubt in your mind, after watching this video, you'll see just how much knowledge this man has. It is, of course, Hambini from Hambini Engineering. If you're not familiar with him, he's made a bit of a name for himself on YouTube for saying how it is. He's certainly opinionated and he doesn't mind calling out on the bullshit from the big manufacturers like Trek, SRAM, Cannondale, you name it. If they aren't doing their job properly, he'll say it. So in the video, we talked about everything to do with bearings and how they're designed and used in the bike. We really get into the weeds. Do bear with us, obviously, with everything that's going on in the world right now. We're having to do these sorts of chats with video link via Skype, etc. So it does drop in and drop out a bit, and unfortunately there's a few disruptions here and there, but it's definitely a really good video and a really educational. I learned a lot. I certainly make myself look completely stupid compared to somebody with a brain this size. So without further ado, let's talk to Hambini. Basically, yeah, I mean, you do more road stuff, don't you? You're like a roadie, effectively.
Well, I'm not even a cyclist. I just got into this by accident. I only use the bike to get from A to B, and then I got a bit pissed off by all these, what can I best describe them as, wankers pulling a fast one, and then I just started making my own bits. So that's how it went from there, really. So I'm not a competitive cyclist by any means.
What's like? I mean, I'm really crap on the road. I'm an old school mountain biker, raced and all that sort of jazz. But I'm really crap because it's a completely different discipline. But I'm like, my average speed's like, mate, I'm just pushing 15 miles an hour now. And that's because obviously I've been going out on the road bike a bit more because of this lockdown stuff rather than going on the trails. What sort of...
I mean, on a road bike, on a good day, I'm doing 20 miles an hour, so 32 kilometres per hour. Not by any means rapid at all. So I just use it mainly to get from A to B. That's
fair enough, then. Right, give us some of your background. So you're in aerospace. And you make bottom brackets, so...
All right, so so I've been in aerospace for, I don't know, 30 years plus. And in there, we get all sorts of things coming along. Like every now and again, there's you get the odd cycling team coming along and saying, make us more aerodynamic. You get the bobsled team coming along and saying, make us faster, and all of this stuff. So my specialty is in aerodynamics. It's not in bottom brackets. The bottom brackets is literally just, it's not even something I put my mind to. It just came and I just carried on doing it. So the bike I had a problem, so I went about fixing it, and then just out of chance, while I was in the bike shop, one of these bicycle distributor people turned up and said, where'd you get that from? So I told him I made it, and then he bought a load of parts. Now the reasoning behind making these parts is it's a quick and easy way for them to fix a warranty claim.
Yes.
So
I picked up on it.
So you probably figured out that's what they do. So you make the bike frame not so good, and then 90% of people won't have a problem with it, but you've got inferior performance. And the 10%, you can alleviate 8% of that 10, or 80% of the 10, however you want to look at it, 8% of the total, with one of these bottom brackets. So then you only have to pay out on 2% of the claims.
So just to explain,
but that's
sure. So just to explain that,
I watched that on one of your videos when you were talking about one. I think it was on, I can't remember now actually which bottom bracket it was, but it was one that had particularly large bearings, and you were talking about the particularly large fit press bearings are much harder to line up, especially in carbon fibre, where they're not using an aluminium lug or bottom bracket or shell or whatever, because obviously you've got to then machine it basically, because it's kind of like they're making the frame
aligned, and then when the carbon sets, it misaligns. If that makes sense, I think.
Yeah.
Like I say, I'm a bit of a dickhead. So just to explain that, what effectively, in your opinion, then it's what's happening is they're making the frame in a particular way so the frame doesn't fail, but then they're putting all the pressure on the bottom bracket manufacturers to basically work in a much narrower parameter to get it right. And if they can't make it then work, it becomes a bottom bracket issue and not a frame issue. But realistically, the foundation of the problem is the frame. Is that?
It's very difficult for the average bike shop to have the measuring gear to tell you that bottom bracket is not to specification. You know, they don't have all the measuring tools, all the alignment tools, and all of this stuff. Plus, I don't want to be disrespectful to bike shops, but a lot of them don't have the expertise to use them. Yes. So when that situation arises, the final customer, is between a rock and a hard place. So he's got this problem, but is it a problem with the bike or not? And he can't tell if it's with the bike or not. So they just go around spending money willy-nilly on bottom brackets. Every now and again, you will get a frame where categorically it is the bottom bracket that is the problem. And then the manufacturer will want to fix that as cheaply as possible because they're generally ruled by accountants.
Yeah, of course. Yeah, they're all owned by sort of hedge funds and stuff. These companies.
Yeah. So if they spend, I don't know, 100 quid or whatever it is on a bottom bracket versus having to take that bottom bracket back, measure it, refix it and send it back, that 100 quid seems quite cheap. So they can just get a 100 quid bottom bracket to fix the problem. So that's how my bottom brackets started off, really. And then from there, I didn't actually make it for a creaking problem. For a performance advantage. But one of the side effects is, I suppose you're recording this, but these things, because they're one piece, they don't have a joint in the middle. So if I get one that's popular in the mountain bike industry, so one like this one, which is a Praxis, that screws together. As it screws together, there is a bit of a gap between the threads to allow you to screw it together. If it was infinitely tight, you wouldn't be able to screw it together. So in effect, in there is a bit of misalignment.
Right, okay.
In that, because it's one piece, there is still misalignment, but it's only my machining misalignment, which is very, very small in comparison.
Right.
Now, if you have bottom brackets where you've got basically that goes in one side and the corresponding side, which is quite common in mountain bike scenarios, you're completely reliant on the frame for the alignment. So that's the problem. It's much more difficult to align a frame because you can put that in a lathe because it's dead easy to hold. You just grab it like that, and then machine it. But if you've got the final bike, once it's been cured and everything like that, and you're trying to machine a hole in there, it's difficult to hold a frame. Very difficult.
You talked about how they also, you've noticed on some frames, they machine one side, then they machine the other, and what you need to do is do both at the same time and effectively have a jig that holds that all together so it's aligned when it's done. Is that?
Not quite right. So if that's the bottom bracket, and that's the cutting tool, when you put the cutting tool in, the cutting tool tends to be on one side. So I'll machine that side. Okay. If I carry on and then machine that side, those two should be in line.
Gotcha.
If you take this out and then turn it, I've now got to make sure that I hold this in exactly the same place. So it's doable, but it's more difficult, and then that takes time. And then you have to use something like a dial test indicator to set it up accurately.
Right.
And your experience, what we seem to be seeing is the problem is then down to, because of these hedge funds that own all the big bike companies, effectively they farm the manufacturing out to China and places like that, which is fine, but they're paying for the budget service effectively, and they're not getting the QA and the QC. And this is where it's, because it's cheaper to do it that way rather than doing it the better way, or it's cheaper to just not get the frames checked and be aligned and all, you know, go through all those processes. And that's where this is kind of like going wrong effectively.
Yeah, so there's that aspect, which is, you're quite right in the sense that the way the world has gone, at the time when manufacturing moved to the Far East, people attributed that, you know, the bottom bracket problems they actually attributed it to press fit bearings.
Right.
Because they were all threaded for many, many years. Sorry, press fit bottom brackets. But the reality is, you know, if you take your car, for example, as you mentioned, your Subaru, all of those bearings are press fit, and they don't give you any problems.
Of course,
Wheel bearings are press fit. So it's not the engineering method, it's the execution, which happens in China. So, for example, you know, if you were to take a small part like that bottom bracket, and I say I machine from one side, in China or wherever, I'm probably doing them a disservice. If they flip it over to speed the process up, you've got a fault in there, but you've got this cost saving for the time that has been reduced, but the performance is not as good. So you can't have both.
It's not the Chinese or the manufacturing's fault as such. It's the service it's being paid for. You know, if you've got an accountant, like you say, saying, okay, let's get it done. Where can we save a couple of pence per frame? Where can we save cents and dollars and whatever else? That's where they do it. And it's as a CEO of a company, or anybody that owns or runs a business like yourself, the buck stops with you. You make that decision. So, and that's what's happening, isn't it? The decision's being made by a group of accountants, effectively. So, we talk about creaking bottom brackets. We always think of a creaking bottom bracket. If you go online onto YouTube and everything, there's loads of so-called like experts out there that will go things like, well, you need to take your bottom bracket out, re-grease it, go through all the normal maintenance. One of the things that I think happens a lot, and I had a video that went live earlier, I think about a week ago, on some pedals, and it got a massive backlash because I slagged off a pair of pedals. I said the dog shit, and it got a lot of, because they are basically, but it's because, I'll explain in a minute. It's because there seems to be an attitude in the whole of the cycle industry in terms of, I'm not just talking about people in the industry, I'm talking about the consumer. We have seemed to have made ourselves a scapegoat and gone, if something's wrong, it's usually down to us that aren't maintaining it right. And that seems to be, it's weird. It's like the blame is shifted. So if you've got a creaking bottom bracket, it's probably my fault because it's my bike and I've probably jet washed it or done something wrong. Whereas realistically, potentially, it's probably down to a manufacturing defect somewhere, or like I say, we're talking a very slight misalignment, aren't we? And that wear has caused it, maybe. Yeah,
the crux of it fundamentally is down to pennies, cents, and euro cents, or whatever, dollars, because the customer doesn't want to pay for, or the customer perceives a certain cost for a certain item. Right. So if you go to your local Decathlon and buy a bike, you expect to pay a certain price. If you go and buy a Trek top of the range bike, you expect to pay a certain price. But you also expect, when you buy the Trek top of the range bike, to have, you know, good engineering, proper QA, QC, proper this, that, and the other. The reality is the difference between the Decathlon bike and the Trek bike, in terms of those things, is not very much. But when the guy goes to the shop to buy it, Trek's whacking in loads and loads, or any other bike company, I shouldn't mention Trek, the margin that they're making is much higher. So, I mean, you could take it as a car industry as well. If you buy a Kia, which I guess in the UK, or a Hyundai or something, is I mean, it's no longer a cheap car, but it's at the cheaper end of the spectrum.
Yeah.
You buy an Audi, okay, if you buy an Audi car, they're probably making a bigger margin on that than the Kia, even though internally, they're still cars, they've got seats, this, that, and the other, but that's the difference.
Yeah. So, and I suppose with the Audi, you just expect it's more on the assembly line. It's probably a little bit better quality control there, maybe, I suppose. I don't know, maybe it's just they use leather instead of plastic, and it just looks nicer when you get in it.
Well, I mean, if you take the car industry as a whole, the panel gaps on Japanese cars that I've found, like Hondas, is really, really good because they are experts in repetitive manufacturing.
Of course,
Whereas,
right.
whereas you take something like, and I used to have a Ford Focus, the panel gap was crap. And an old Ford Fiesta, it was just garbage. So made in Germany, but absolute shant. So that's the difference. The engineering expertise is different. So, I mean, the expertise in carbon fiber is the high technology is in the aerospace and F1 industries, probably more in F1 than in aero,
Right.
because the speed to actual implementation is much faster.
Process, yeah.
Yeah. And there's less regulation you have to follow. But in aero,
it work in F1, so yeah.
In aero, the certification takes a lot longer. But then the speed, but then you see, so that's the niche market, but the mass production tends to be in China and Taiwan because it's a manually repetitive process. So it's a manually intensive process, building a bike frame. So that's it. I mean, in mountain bikes, one of my pet hates is these lugged frames that I think you sent me a link for.
I talked about it. I know you said that you had no experience with it, but it's because I watched a video where you talked about 3D printing.
Yeah.
But you were saying about the lug frames, yeah.
The lug frames, so that's round tubes with the joints. Now, when I've seen these made in various places, they tend to put the tube in and then wrap it round like a bandage almost round the joint.
Right, okay.
Now, when I've experienced this sort of joint, in industry, so not on a bike, those joints have been inherently weak because they're quite good in shear. So shear is, I can't describe it. Shear is, like rubbing, is like trying to, if you put sellotape onto a table and then try and pull it horizontally, that's shear.
Okay.
But then when you try and lift it, it peels relatively easily.
Yeah,
when you find the lifting force, it's crap. Whereas a unibody construction is much, much stronger.
That makes sense. Yeah. Okay.
Yeah.
So if it was twisted, if you've got that tube and that lug, if it's twisting around the lug, it's quite strong. But if you suddenly got a torsional sort of load on it, it's not as strong on the joint. I mean,
a static blow.
I remember you probably not been into cycling as much, but I remember the old GTs. There was a lot of old bikes back in the 90s, the late 90s that had they were thermoplastic, so they weren't like carbon, but they were basically I think we used to call them thermoplastic, which is probably like an early sort of weave of type of carbon, I think, or something like that. But they still had aluminium lug headsets, but that's where they all failed. They all would develop play in those areas because I suppose at the time in the 90s they just didn't have. Maybe they did, but maybe it was just far too expensive to have the correct adhesion and stuff like that to sort of make it work. So, I mean, we talked about I keep calling it robot bikes. It's out of the Atherton brand, which is what I sent to you. One of the things that's really good about the Atherton bike is because they 3D print these lugs and effectively these tubes must all just come in different random sizes. They can make the bike custom to the rider, so it's a very quick and I think quite a cost-effective way of having your own custom frame. Usually, to have that route, you'd need like a classic frame builder that builds steel frames, somebody like Starlin, who's based down near you guys, now where you are, Bristol way, who builds a steel frame, and then you've sort of lumbered with only steel as a material option. And then like with Atherton bikes, you go along, I think you fill in like a bit of a spreadsheet. This is another problem with having a custom bike as well, is because most riders don't actually understand the geometry of a bike and what different things do, and they kind of say things like, well, I want a longer reach and a shorter reach, but the truth is that might not necessarily benefit their riding style, especially on a mountain bike. But for example, if you sit down with somebody at the manufacturers and they take you through the options and they know what they're doing, you end up with a bike that perfectly fits you. And obviously that's a much bigger benefit than probably anything else you're going to do to that bike, is having a bike that actually fits you. But the downside to that, I spot on one of your videos I noticed you talked about 3D printing, and 3D printing just hasn't got the strength compared to regular manufacturing. So why is that? What is it about the 3D printing then? Is it just...
I could get really, really technical, but I could also try and explain it simply. And I guess for your viewers, simpler is probably the better method. but
for me, it's probably the better method.
3D printing is almost like you're getting grains of sand and then gluing them together.
Okay.
Yeah, to generate the part. It's not a fluid structure. When you want to make something very strong, you tend to forge it. So 3D printing is more like casting, where you get the material and you melt it and then mold it into the shape, and then there's your casting. That's done. Yeah. But inside, the grain structure is not very strong. Forging is when you get the material and then you actually press it into shape, right, under high pressure, and often with heat. Depends if it's cold forged or not. But in that scenario, the grain tends to be more compacted in areas where it needs to be. So it's much, much stronger. So things that are under heavy load, like heavy load, like crank arms, they tend to be better forged rather than 3D printing. I mean, 3D printing is all the rage because you can go on eBay and buy a 3D printer and then print this, that, and the other. But if you want high load, you either have to compromise on strength or design the part so it has a lot more redundancy, like ribs and strengthening features that the non 3D printed part doesn't need.
So the non 3D printed part could effectively probably be made lighter and sort of more efficient. So I mean, to me, it seems that everything's always got a compromise. So you want a frame that's sort of custom built. The compromise is that then you're going to be compromised on strength or maybe performance. But then what doesn't make sense to me is there are other bike brands out there. I mean, there's so many bike brands we don't even get in this country. There's a great one in Italy called Ancelotti, and they make custom fit bikes, and people complain because it's a 6-week lead time. But personally, if I was ordering a bike and it's custom built for me, that was actually an exact size that I specified, 6 weeks doesn't seem a long time to me. It's just a month and a half, isn't it? So, no, that's quite interesting. Hope technology then, because I know you regard Hope quite high in terms of because I think they're known as the largest bottom bracket manufacturer in the UK, and that's something that you kind of aspire to be.
And that's something you kind of aspire to be.
I don't think I'll ever do it, but there you go.
Hey, you gotta have things.
I don't actually understand my notes. So basically, I was making notes as I was watching your video, and I've made a note here that says Hope Tech and the 41mm by 30mm bottom bracket. Is it right?
No.
What's wrong with that then? Tell me.
Let me just see if I've got a prop. So here's a bearing from a 30mm bottom bracket. So something like a PF30, BB30, BB386. So that's from a 30mm bottom bracket. There's a 25. So let's put that bottom bracket. There's a 25mm bottom bearing from a Shimano bottom bracket. Okay. This one actually is a fake that someone sent to me. So, and that is a 4130 bottom bracket.
Okay.
So you can see how slender that is, I hope.
Right, got ya.
Is that better?
Yeah. No, that makes perfect. Yeah, it's perfect. I can see that. Yeah.
So that is what is taking your load. So you can see the size difference.
Right. And is that purely just then a strength thing? It's just more load and it takes more wear. Or
so Shimano's designed their standards. So BB86, BB92, and is it BB89? I can't remember in MTB. Whatever it is, anyway. They've designed that to stop people using 30mm axles in those frames.
Right.
And there's various ways to get around it. And one of those ways is to fit fairly slender bearings. So you can that will fit into a BB86 frame, but you can. I mean, it almost feels like a toy in my hand. And that's the problem.
Is it a reduced performance you get from a bearing like that? Is it, or is it just purely what's the word I'm looking for? Longevity.
Right.
Yeah.
It's a combination of both. The biggest differential will be in life. So you get something called the C rating, which is a measure of how well. The technical measure of how long a bearing lasts is called its L10. You also get L10, L2.5, and all these other ones, but it's how long 90% of bearings will last.
Right.
If you pick one of those slender bearings, it's about a quarter of the time that it will last.
Really?
It's not 25% less, 75% less.
And what's the benefit? Is there a benefit?
I don't think so.
So there's not a benefit in performance?
Oh no, there is no benefit in performance. The only thing is it allows you to fit a crank that you might have lying around in your frame.
Right.
But if you have the choice, don't do it.
Fair enough.
The same thing applies for dub as well. So the SRAM dub standard.
Right.
That's fitting that into a bottom bracket which has a 41 millimeter hole is not a great idea.
So I mean, we're not criticising Hope there, are we? Because generally, your opinion is Hope are quite good in terms of what they do, isn't it? I mean, it's just they've obviously recognised a hole in the market that they can fill with that, because obviously people come along. It's a consumer-led thing, isn't it? People have come along and said, "I want this to fit this bottom bracket."
There's a demand for it, so they'll make it. Now, loads of people have asked me to make them for it, but in my world, my reputation is more important than anything else. So I just said no, basically.
Yeah. Well, I suppose what it is.
Well, any small business, your quality has to remain higher because you're building a reputation. When you get to Hope's level, where your reputation, I mean, and this is what I was going to talk about earlier, was there's a user bias, like an unconscious bias with consumers. So they just take it for granted that Hope's stuff is the dog's bollocks.
We have this sort of bias. It's weird that we hold companies. We don't think people just go because it's fine. Well, it's my fault because I didn't check the bolt. Or well, you can buy a replacement part for £3, but I shouldn't have to. And this is the thing. What I really liked about your videos was calling out the bullshit in the cycle industry, because it just, like you say, it's all marketing. It's all marketing, and it's our fault. And then you go to the bike shop, and this, that, and the other happens, and it all kind of the blame gets passed around, but nobody takes responsibility. And then says, "Well, we just need to make things better."
The bike shops themselves are partially to blame, because if we go back to the penny pinching, as it were, a load of them are selling fake parts. Loads of them are selling fake parts, and they just they're passing that on to the consumer, and the consumer's not getting the performance that they pay for. So just when
you say fake, like literally they're buying them from China, or is it fake stuff that's being filtered into the market? How do you mean?
So this bottom bracket, it came back to me, and the guy said, there's a fault with this bottom bracket. And now one of the things I state, because I've come from industry, is the bearings will wear out, but provided you put in decent bearings, I will honour the warranty on the bottom bracket. So he took the original bearings out, or the bike shop took the original bearings out and replaced them with NTN bearings.
Okay, right.
And then he still has some problems with it. And then I got all these emails going, Hambini, you're a fucking idiot. You're a fraud, this, that, and the other. And I said, okay, fine. Send me the bottom bracket. I'll have a look at it for you. Got the bottom bracket, and the bearings inside said NTN on them.
Right.
Well, they transpired. They were fake. So...
Because NTN, they're quite a high manufacturer. I think their base is around the corner from us, actually, down in Lichfield, I think they are.
Yeah, NTN SNR UK is in Lichfield, yeah.
Yeah, that's literally just like half an hour away, just around the corner. So
Yeah.
But past time. So who's making the fakes then? They're just Chinese.
So the Chinese make a bearing, put an NTN sticker on it, and then sell it as real. The problem is it's very difficult to spot the difference between a real one and a fake one. Just to the naked eye, the packaging is really, really good. And then
Rolls Royces, aren't they, the Chinese? So do you know what I mean?
So then the guy puts it in his bike, and if they go and put it in a set of pedals or a headset's the worst,
Right.
and then they don't get the performance, or something worse happens, like they crash, then there's a serious implication with that, especially in mountain bike. Well, even in road, if you're going downhill at high speed and you find your steering doesn't work anymore, that's not really a good place to be.
This is to say, we go back to it because there's so many times I think of as a rider that I've jumped on my bike and I felt like the bearings weren't good, whether it be in my pivot bearings on my suspension, my headset, like I've left it for a bit and it's seized up a bit or whatever, and I've put it down to being my fault. Jet washing, for example, the GCN did a wicked video. Now, I like GCN, I'm not slagging them off at all. I think they do good videos. They're like me. We basically make videos and we use our knowledge. But obviously, when I watched that video where they jet wash a bike and they sort of jet wash bearings solidly for like about 5 minutes and 10 minutes or something like that, and then they pull the seal off or they pull the bearing apart and have a look inside, they're looking for water ingress. But to me, that's probably not that accurate way of doing it, just looking and going, no, I can't see any water. But you obviously know a lot more about bearings. How safe is jet washing your bike? Is it all right, or is it just like a complete no-no?
I wouldn't personally.
No.
Because if you've got bearings with full seals, so the inner and outer race are touching, then those kind of bearings will stand a water jet, but not a high pressure water jet. And that's
Right.
The thing is, you have to put it into context because the bearings are usually buried somewhere in a housing, and for the water to get in there, you have to take quite a tortuous path.
Okay.
But still, if it's under pressure, it's more likely to do some damage than if you just tinkle it with a watering can or something.
Got you. You mentioned the seal then, and that just reminded me as well. A lot of the issues you say with the friction with the bearings in terms of underperformance of the bearing comes down to the seals. It's actually not the bearing itself. It's the seal fitment or the seal pressing against something, isn't it?
Yeah. So if I got a prop. So here's one I chopped earlier. So the bearing, this one. Okay, so it's a big bearing, but you get the idea just so you can see it.
Yeah.
So there's the outer race, the inner race, and this part of the bearing is missing. Usually you'd have a seal that goes between the outer and then touches on the inner. So it's fixed on the outer and it rubs on the inner race.
Okay.
That rubbing causes 95%, well, I can't remember what the statistic is, but the vast majority of the friction. The bearing material has very little effect. Now, inside, the other thing is, if I move that, I don't know if you can see that. This thing here that looks like a ribbon that goes around the balls. In this bearing, it's a pretty high quality bearing because that's metal. Now, in the cheaper bearings, that'll be plastic.
Yes.
So the metal tends to be better because it'll have a small amount of grease between the cage and the ball, so it will spin quite well.
Okay, got you.
That one's an angular contact.
Yes. So these are side specific and angular contacts. So one would be left, one would be right, wouldn't it?
Correct. Yeah, you need a pair really.
Yeah. With
the seals, one of the things, a video we did a long time ago was showing people how to service their own bearings. So, and we kind of did it. We didn't do it as you should be doing this to your bearings. We always say, ideally, if your bearings are playing up, you just want to replace the whole seal cartridge. But if you're getting, we always say like midwinter, you've got a month left or so before summer, you might just want to get another month out your bearings. Carefully pop the seal off, and you can clean it out and re-grease them and pop the seal back on.
Yeah.
I think I know you mentioned something about like the race teams do that quite regularly because they want to keep
Stop you there.
So like the race teams and stuff, they will carefully take that seal off, and they will re-grease and resurface those bearings quite regularly. Is that something?
They take them off and then they use no seal.
Really?
They take them off and then you basically just have they do one of two things. You can buy these bearings with no seal. So the letters after the number. So in this case, it is it's a 6000 series, probably 50. I don't know, 6212 or something like that. But you can buy them without a seal, and you just literally have that. Okay, it'll be all the way around. They just put oil in here,
right?
Put grease in there, and then run. But you can only go for about 50 miles.
Okay.
And then that's it.
So on the track, that would be a good place, but not for the tour or stuff like that. So, there's a longevity.
Contador used to do it. So he used to get his mechanic to take the seals off, fill it with very light oil, and then put the seals back on. So it would hold the lubricant in.
Okay.
And just make the bearings run faster, just give them a few extra watts, effectively. So, whilst we're talking about that seal, I don't know if you had a chance to look at that Cane Creek Neo bottom bracket that uses the polymer. Yeah. What's your thoughts on that?
So that technology's been around for many, many years.
I think, isn't it?
It's from where?
Is it in the food industry? I think they use it in the food industry. I think.
Marine industry.
Marine. Okay, got you.
So the trade name for that is called Solid Oil. I supply Cane Creek with those bearings. Is it called MTRX? I'm trying to remember.
I don't know. That sounds familiar.
I think it's that. Anyway, the SKF have a variety. FAG, who are actually very popular in mountain biking.
Yeah.
And NSK, so they're the big ones. They all have bearings which are solid oil. So where that cage is metal.
Yeah.
You replace that with a polymer that is kind of like a plastic, but it's self-lubricating.
Got you.
But they fill the gap out so no water can get in.
Yeah.
I saw a demo at the show, and I'll be honest with you, I really liked it because obviously it's got a huge amount of reliability in terms of, I suppose the market for it is that if you've got a certain user that just wants to stick something in the bottom bracket and then not have to worry about it, it's going to last a long time. But is there a compromise on performance with something like that? Because when I felt it did feel noticeably stiffer, I suppose. Maybe there's a different word for it, but stiffer. But the Cane Creek chap from America that was sort of said, he seemed quite knowledgeable. He was saying once it warms up to temperature a bit, it actually they reckon it's marginal, the difference between that and a regular bearing. Do you know much about that, or?
So if you were to, I mean, it's more draggy.
For sure.
Without any doubt, has more drag. It's also, when it's subjected to like extreme loading, it's not as stiff as a steel,
right?
As a steel bearing. But these are scenarios which you have to take into account for your particular application. So I would say, if it's going in a headset, does the drag matter? Probably not. If it's going in some bracket where the maximum RPM for a prolonged period is going to be 100, and you're trying to win a time trial on it, it's probably not a good choice. So you got to pick these things up.
Fair enough. No, it's cool. It's cool. You mentioned SRAM earlier.
Yeah.
What is your beef with SRAM?
It's not really a beef. It's one of my pet hates is poor engineering.
Right.
And when someone says something, I expect them to do it. So if they, in my professional capacity, if someone said, I'm going to supply you with a product that does X, for example, you go and buy a car that has 100 horsepower, and they're turning around and supplying something with 90, you'd be a bit pissed off.
Yeah.
So
like
that
the Italians lie about there.
So SRAM GXP, which is my bugbear really.
Yeah.
Their cranksets have extremely poor tolerances on them. Now they don't apply them with a tolerance that says they will be between this number and this number, but you expect them to be reasonable in terms of the number they are supplying them to, and they're not. They're absolute rubbish, drivel.
That's what because you actually talk about quite a lot. You'd love to sit down with some of the people that make these decisions or state these facts. Obviously, certain people in the road world. You talked about FAG earlier. Hunt Wheels, they're a relatively sort of new player in the mountain bike world. I actually looked at getting a pair myself, but you were not too keen on them either, were you? They're sort of, if I recall.
All they're doing, from my research, is going to a factory in China, buying the wheels, and then selling them in Europe and North America with their margin added on. So you might as well just go and do it yourself on AliExpress or something like that.
Yeah, fair enough then. Fair enough.
Taking it back to bottom brackets, because it seems to be everyone talks to you about is bottom brackets, isn't it? Threaded versus press fit then. Is there one that's clearly better, or does it come down to the manufacturing?
Well, all bottom brackets are fundamentally press fit. So the final bearing that goes in. So even this threaded bottom bracket, this is a thread in the middle, but the bearing still pushes in at the end.
Got ya.
So that is, it's not that's the problem. It's the manufacturer who needs to sort themselves out, and that's the crux of it, because they are just putting out generally cheap as chips equipment, and then leaving the customer to deal with the fallout from it, or the bike shop to deal with the fallout from it.
Fair enough then. Okie dokie. The wave washer that you get on a packet, what is the purpose of that? Like
preload system. So
right.
So the best way I can describe this is if you have a bike with a wheel on that's in a turbo trainer, and then when you screw the roller at the back so it touches the tire, if you don't put enough preload on it, or enough pressure on that roller, if you get on the bike and then try and spin really fast, you find the tire slips on the roller.
Yeah.
So all that preload washer is doing, the wavy washer is doing, is preloading the bearings, and the bearings are the same thing. So in the bearing, you want the balls to actually roll. If you don't have enough preload, they skid.
Right.
So that's what the wave washer is doing.
Got ya. Before I forget, we had a question. I've got a little group, about 1,000 people on our Facebook pages. It's like a little sort of behind the scenes group, and we were mentioning things we'd want to ask the experts. One of the questions that somebody did mention was adapters from press fit to screw fit. I think that's the right way around. Yeah, because people have got, or was it? I can't remember. Yeah. He wanted to use a screw fit bottom bracket, but he's obviously got a press fit setup. There are adapters available, aren't they? On some, isn't it? Or is that something more custom? And should you go down that route, or should you just stick with what you've got?
You should really try and avoid it, because each time you put an interface in, you're creating a potential problem. You're much better off trying to find the problem and then fixing that, rather than putting an adapter in to adapt it to something else. So from the sounds of it, if I got a Shimano bottom bracket anyway, I did have, but I don't know where I put it. See, that question is almost along the lines of, he wants to fit a threaded bottom bracket because back in the day he never had a problem with it.
Got ya.
I know that's the way you've asked that question. That's what is glaring out at me.
Right.
You really want to avoid it. You want to avoid it. You can. You want as few interfaces as possible.
So unless he's got a specific issue with his frame that he's trying to solve, in which case, if that was the case, he's better off sending the frame to you and saying, what's wrong here and can you fix it?
Well, yeah, if it's a mountain bike frame, you're probably better off going somewhere else rather than me. I found the Shimano bottom bracket.
Cool, go on.
So in order to turn that press fit into a threaded, you would need to put a press fit to threaded adapter and then thread this in for a final press fit bearing. So you've got so many interfaces there, and that's something you want to avoid. It's engineering wise, it's bad practice, because each of those interfaces has a fit, has a tolerance. So yeah, you want to avoid it.
You want to try and simplify it rather than overcomplicate things, basically. So
you don't call yourself a bearing expert, you call yourself an aero expert. Aero in mountain biking, do you think it makes a difference? Do you think it matters? Does it always matter, no matter what?
I wouldn't even say I was an aero expert, so that's I think my colleagues would describe me as a cunt, but there you go. Aero in mountain biking, the problem with aero mountain biking is fundamentally, in order to keep control of a mountain bike, you have to have your hands quite wide apart, and that screws up your aerodynamics.
Yeah.
So, you know,
because you've seen the clothes we wear, you've seen the clothes we wear. They couldn't be less aerodynamic if we tried. Do you know what I mean?
Yeah, the flapping.
Let's dress up leg outfit.
We're back.
That's a good line now.
Is it? I'm not going to continue recording. I think we're pretty much done. So we're all right as it is. I think when I...
All right.
Oh, mate.
Have a nice day, Andy.
Yeah, you too, but take it easy. Ta-da. Bye-bye. Bye.
How good was that? The connection got a bit bad towards the end there, and we were struggling to sort of hear each other. So I'm not quite sure how it played out on the end on the camera and what got picked up. I hope you enjoyed that. I hope you learned a lot. Really interesting stuff talking to him. The man is clearly very smart and properly understands engineering and design and how it all works and how the systems work. You can tell he's part of the process, the behind the curtains, the wizard behind the curtains, as it were, that we don't get to see. If you like the video, please do give it a thumbs up as always. If you didn't, give it a thumbs down. But if you've stayed this long and you didn't like the video, more fool you. Give it a subscribe. Make sure you hit that notification bell. All the usual jazz. And let me know what you thought in the comments. I really want to hear your comment. I really want to hear from you on this one, as always. But if you've got any more questions, maybe we can follow it up later with an interview further down the road, and maybe even pop and see Hambini and chat to him about any other questions you may have. Or if you've got any other engineering or design or whatever questions there may be about the bike industry, be sure to let us know in the comments, because then we will find an expert and a professional who we can talk to and maybe answer it. Until next time, guys, see you later. Ta-da.